Arrangement of electrons in an atom. Now we have learnt that electrons are negatively charged and they are present outside the nucleus. These electrons, they form a negative cloud outside the nucleus and they arrange themselves in energy levels or called shells. Like in the picture we can see here, we have the nucleus in the center which is positively charged, and the electrons arrange themselves in shells. The first shell here is called the K shell. It's the energy level which is the lowest. Then we have the next is called the L shell, where the energy level is a little higher. Then we have the M shell. The third shell is called the M shell, and in the end we have the N shell. Of course there are more shells too, but it's enough for you to know till these shells. So the first energy shell or the first energy level is the K shell or the K orbit. Then we have the second energy level, and the second energy level is called the L shell. We have the third energy level. Third energy level is called the M shell, which has got higher energy. And then we have the fourth energy level, which is called the N shell. So K is always we denote as n equal to 1 because it's the first shell. The L is n equal to 2. It is called the second shell. M, we say n is a number of the number of the shell. We call it as 3, and n we call it as 4. Like here you can see the first energy shell, which is K. Then we have the second energy shell, which is L. Then the third energy shell, which is M, and the fourth energy shell, that is N. So to recap here, electrons are arranged in shells or in energy level, starting from the lowest close to the nucleus called the K, then the next is the L, then is the M and the N shell. We'll now see what you mean by electronic configuration. The arrangement of electrons in the various shells or the energy levels of an atom, of an element, is known as electronic configuration. Now we know we have a couple of shells like K, L, M and N. Our shells are K, L, M and N, and these can accommodate electrons. Now the electrons accommodated in each shell is not equal. We will learn now how to arrange these electrons in these different shells. Now for the first shell, the first shell or the first energy level is K, and we have N equal to 1 because it is a first shell. The electrons that can be accommodated in this shell, the maximum electrons, is given by the formula 2n square, which is now 2 for the K, N is 1, so n square, which is 2. So in K shell, the maximum electrons that can be accommodated is just 2. So hence here they have K shell, maximum electrons 2. Now we go to the next. The next shell is the second second energy level, and we name it as L, and it is second, so N equal to 2. The formula for maximum electrons that can be accommodated in any shell is 2n square. In this it will be 2, your n we know is 2, so 2 square, 2 into 4, that is 8. So in the L shell, maximum L shell, 8 electrons are accommodated. Then we go to the M shell, the third shell or the third energy level, which is M, N equal to 3 because it is third, and the formula for maximum electrons that can be accommodated is 2n square, which means it is 2, your n here is 3, and 9 into 2 is 18. So in the M shell, a maximum of 18 electrons, here they've given you 18 electrons in the M shell. Then we have the fourth shell, and in the fourth shell, which is the N shell, N equal to 4, so maximum electrons, we know the formula 2n square, so that is 2n is 4 square and 32 electrons. So in the N shell, 32 electrons are accommodated. Let's recap about the shells. So we have the electron shell, we have K, L, M and N. Now for K, the number of shell is 1, and the number of electrons it can hold is given by the formula 2n square. So 2 1 square, which is 2. So the K shell can hold 2 electrons, maximum capacity. The L shell is the second shell. Electrons it can hold 2, N is 2, so 2 square, which is 8 electrons. Then we come to M shell, third shell, 2n square, n is 3 here, so here it can hold 18 electrons. And then we have the fourth shell, that is 4n square, n square is 16 into 2 is 32, so it can hold 32 electrons. Now, however, although the M shell can hold 18 electrons, once an orbit has got 8 electrons, it becomes stable and it does not hold more than 8 electrons. So we can write here the outermost orbit or the outermost shell cannot accommodate more than 8 electrons. Even if its capacity is to accommodate more, is more. So the M will accommodate only 8 electrons, the N will accommodate only 8 electrons, although it can accommodate 32, but yet it will accommodate only 8. However, the first shell accommodates only 2, it cannot accommodate more than that. L shell will accommodate 8 electrons. Write the electronic configuration of oxygen. The first thing we need to know is atomic number, oxygen. Atomic number equal to 8. So protons are equal to 8, so electrons also will be equal to 8. So number of electrons equal to 8. Now our shells we know are, we have the K, L, M and N shells. Now there are 8 electrons to be distributed. The first one will 2. So out of 8, 2 are here, so 6 remain, and there will be 6. So these 2 shells will not be present. So this will be the electronic configuration of oxygen, the distribution of its atoms. 2, 6. 2 in the K shell, 6 in the L shell. Next we'll take sulfur. It's very important to know the atomic number. Atomic number of sulfur equal to 16. So protons are 16, therefore number of electrons is also 16. So again we have the shells K, L, M and N. Now there are 16 electrons to be distributed. In the K only 2 can fit, not more than that. Then we have 8 electrons in the L. That becomes 2 plus 8, 10. We are left with 6. So that is 6. So we will not have this. If you see, if you add up, you get this is equal to 16. If you add up all the electrons. So this is the electronic configuration of sulfur. 286. Next we'll take up calcium. Atomic number equal to 20. Number of protons 20, so electrons also equal to 20. Now we need to distribute them in 20 electrons have to be distributed in these 4 shells. So the first one always takes up 2. So out of the 20, 2 are done. Then we take another 8, so 2 plus 8 became 10. Remember we have to distribute 20. We have 2, then we took 8. Now and then we take another 8. So now we've got 18. Now out of 20, only 2 more are left, so 2. To make sure that it is all right, you need to add up all and see. If you add up all this, you will get 20, which is the number of electrons. So that is the electronic configuration of calcium. So once atomic number is given to you, you can write the electronic configuration of the element as a distribution of the atoms of the electrons. So here it's a nucleus. We'll have the first shell. In the first shell there will be 2 electrons. Then you'll have the second shell. In the second shell you'll have 8 electrons. Then there will be the third shell. In the third shell again 8 electrons. And in the end you have the last, the M shell, and in that you'll have just 2 electrons. Of course you need to complete your shell. This would be your atom of magnesium, of calcium. If you go back here for sulfur, you have your nucleus. It has got 3 shells, you can say K, L and M. So you have the K shell first, then the L shell, and then the M shell. In the K shell, you see the first shell, there are 2 electrons. Then there are 8. And last there are 6. This would be the atom of sulfur. Now for oxygen, it has got 2 shells, the K and the L. In the K shell, always 2, and the L shell there are 6. This would be an atom of oxygen.